Hello, good day everyone. I welcome you all to this channel with Islamic greetings. Assalamu alaikum wa rahmatullahi wa barakatuh. So in today's lesson, we look at the last two laws of indices, which is the fractional power law of indices and the negative fractional power law of indices. So let's start with that. Okay. Now, what do we understand by fractional power law of indices? It's very simple to express. Let's consider an expression like this. Given a base A, of which the fraction is x over n, just like this, an expression like this. What this law is going to say is that whenever you have an expression like this, you have a numerator of x and you have a denominator of what? N. You form a root like that. But the root takes the name of the denominator. The denominator in this case is what? N. So that will be nth root. Just put the denominator here, then you take the base, put it here, then put the x here. That's how to express it. Consider an expression like this too. 9 raised to power 1 over 2. Follow the same thing. You can see the name of this root now. We have a root already. The name of the root is going to be a square root. You can put the 2. Then we have 9 all raised to power what? 1. Can you see that? So this can also be like this. It can also be expressed in this form without putting the 9. But you can also put the 1. The 1 won't affect anything, okay? So, but you may decide not to put the 2, you may decide to put the 2 because square root sign is already this, so you don't need to put the 2 again. But if you are putting the 2, be careful, or if you are putting any number here attached to that root, the number must be small, not big one. Okay, so that's why you can see my 2 is very, very small here. So that shows the square root of that 9. So this is equals to 3. When you look for the square root of 9, you give 3. Let's consider another one. 27 raised to power 2 over 3, of which the name of the root here is going to be what? Cube root, because you're having a denominator of 3. So it's going to look like this. Small 3, then you have 27 all raised to power 2. So the cube root of 27 is 3 raised to power this 2, and that will give us 9. So that's how to express fractional power law of indices. So let's move to negative fractional power law of indices. We also consider the same expression. A raised to power negative x over what? N. So the difference between these two is that you have a negative here, you don't have a negative here, okay? But you still have the same law, you still have a fraction, okay? Now, what you should do here, don't forget that I expressed something like this in my last video on this topic. I said whenever you have a negative like this, 1 over a, that negative turns to 1. So that's why you need to follow me on this channel. Just watch the videos, okay? I put them step by step. So this negative here will turn to 1 all over a raised to power x over n. So you can see that in the denominator that we have here, which is a raised to power x over n, is now expressed like this. So you are going to have 1 over the nth root of a all raised to power x. So as simple as that. So let's use the same thing. 9 raised to power negative 1 over 2, of which the negative is 1 over 9 raised to power 1 over 2, right? So this is going to be 1 over square root of 9 all raised to power 1, and that will give us 1 over 3. So this is same thing as saying raised to power negative 1. Let me use all. 1 equals 4. Alright, so let's also use the last one. 27 raised to power negative 2 over 3. This negative is 1 over 27 raised to power 2 over 3. So this is going to be 1 over cube root, because you're having 3. Don't forget that. 27 raised to power 2. And this will give you 1 over 9. Because 3 raised to power 2 gives what? 9. Okay? Or so this is how to express fractional power law and negative fractional power law of indices. And that will mark the end of today's lesson. But if you have any question on this, you can drop in the comment section. Don't forget to like this video, share this video, subscribe to this channel, turn on the bell notification to receive any updates from this channel. I'll see you guys in the next one. Bye for now.